video is to help you to understand how to subtract unlike fractions. A couple reminders before we get started. Unlike fractions are fractions that have different denominators. If in my equation I'm trying to subtract two fractions and these fractions have different denominators, then these are unlike fractions. However, when you subtract fractions, you need to have like denominators. You can't do 1/6 minus 2/3 without finding a denominator that's common to both of those fractions because they are unlike. Excuse me. One way we can do this is to use your fraction bars. So let's say my first problem, my first equation is 5/8 minus 1/4. Well, the first thing you're going to want to do is to put your 1 bar down and place 5 1/8 bars under the bar for 1. So I have my 1 bar and I have 5/8. So I've reached into my bag and I found 1, 2, 3, 4, 5 1/8 pieces. So that's 5/8. Then place 1 1/4 bar under the 5 1/8 bars. So I have my 1, my base, 5/8, 2, 3, 4, 5, and 1 1/4 piece. So this tells me, this layout tells me that this area right here, that's the difference. That's the difference that I'm looking for between 5/8 and 1/4 is this piece that's missing right here. So now all I have to do is compare my fraction bars and find the bars that fit exactly under the difference 5/8 minus 1/4. Well, it's easy for me to look here and see I could take those 3 1/8 and slide them down and they're going to fit perfectly into that space. So this tells me the difference in 5/8 and 1/4 in this space I could fit 3 of these 1/8 bars. So 3 1/8 bars fit. So 5/8 minus 1/4 would be right in here. That would be an 1/8. That would be an 1/8. That would be an 1/8. So I know that it is 3/8 is my difference. Here's another example using fraction bars, and this time it's a little different. In the last one, we were able just to slide down those extra fraction bars that were hanging off the end because they fit in perfectly. Well, let's look at 2/3 minus 1/4. First thing you're going to want to do is put down your 1 bar to have your base, and you're going to place 2 1/3 fraction bars because in your equation you have 2/3. So down here I have 1/3, there's another third, so I've put my 2 1/3 fraction bars under the bar for 1. Then I'm going to place 1 1/4 bar under the 2 1/3 bars. So I'm just stacking up my equation. 1 is my base, and this tells me that I'm looking at 1 2/3 minus 1/4. And this space right in here is the difference in those two fractions. Well, if I look at that, I see I can't slide those pieces down because my 1/4 kind of cuts off right here, and I can't slide down a part of a 1/3. And the 1/3 will fit, but then I've got like a funny gap there. So I'm going to have to find fraction bars that are equivalent to 2/3 and 1/4. I have to find pieces that will fit nicely under my 2 1/3 and under my 1/4. So I dug around in my bag, I tried all different kinds of pieces, and I found that my 1/12ths would fit. So I pulled my 2 1/3 off to the side, and I grabbed all my 1/12ths, and I found that I could fit them right up underneath there. So I see here that 2/3 is equivalent to 1, 2, 3, 4, 5, 6, 7, 8 1/12ths. It all fits very nicely. So then I had to pull my 1/4 out and see if the 1/12ths would fit under there also. And I'll see that I can put 1, 2, 3 of my 1/12 bars underneath my 1/4. So here I have equivalent fractions. I see that 2/3 over here is equal to 1, 2, 3, 4, 5, 6, 7, 8 twelfths. And I've also found out that 1/4 is equal to 1, 2, 3 twelfths. So now I have to go back and compare the rows of bars, this row compared with this row, and find the number of 1/12 bars that fit exactly under the difference. So what I've done is I've replaced here my original with these are now here. I've pulled up my 1/4, I've put in my 3/12, and so I've built this equation with my fraction bars. This is exactly the same as this, but now my denominators are the same, whereas here they're 3 and this one's 4. Now they're all 12ths. So now it's easy to look and see how many of those pieces could I slide down and fill in this box, because this box represents the difference in 2/3 and 1/4. Well, now it's easy because I can match 1, 2, 3 there, and I have 1, 2, 3, 4, 5 left over, or 5 that could slide down into that box, and that tells me the difference. So this way I've had to find equivalent fractions, 1/3, 2/3 here, and 1/4 here, and just rebuilt my original equation. There's another way, just like when we're adding fractions, another way that we can solve for this fraction problem is to find the least common multiple. The least common multiple of the two denominators will be the new denominator in the equation. Well, we know we have to first go back and find all of our multiples for both of these denominators. So I'm going to do 4 first. 4 times 0 is 0. 4 times 1 is 4. 4 times 2, 4 times 3, 4 times 4, 4 times 5. And I'm going to stop there. If I need to go out further, I will. Now I'm going to find all of my multiples of 3. 3 times 0 is 0. 3 times 1 is 3. 3 times 2, 3 times 3, 3 times 4, 3 times 5, 3 times 6. And I'll go out further if I need to. So now I have to look which ones are common. 0, but I know I can't use 0. 4, 6, 9, let's see, they both have 12, 15, 18. So that's all I really need, because now I know that the least common multiple is 12. So 12 is going to be my new denominator over here. And now what? Well, this is where I call my hero friend, the backwards Z guy. He's very happy to come and assist. And so I call, backwards Z guy, come and help. What do? I have to make equivalent fractions now. I could say 4 goes into 12 3 times. 3 times 3 is 9. And there's the backwards Z guy. He's hiding right there. 3 will go into 12 4 times. 4 times 1 is 4. Now that my denominators are the same, all I have to do is subtract my numerators. Well, 9 minus 4 is 5, and my denominator is 12. So it's very, very similar to adding fractions with unlike denominators. Just make sure you always check that sign so that you know you're performing the correct operation. The last example, again, just like when we added fractions, you can use the butterfly method to subtract fractions with unlike denominators. So my first equation was 3/4 minus 1/3. I butterflied him out. 3 times 3, underneath the antenna, I put a 9. Butterfly this. 4 times 1 is 4. But remember, when you're adding and subtracting with unlike denominators, you have to multiply your two bottom numbers to make the tail. 4 times 3 is 12. So now I just subtract. 9 minus 4 is 5. And I bring my product here over, and 5/12 is reduced to lowest terms. All right, let's try one more of these. If I have 1/2 minus 2/5, and I want to use the butterfly method, I'm going to go 1 times 5, 2 times 2. I'm going to add my antenna for my butterfly. 5 times 1 is 5. 2 times 2 is 4. Have to make his tail. 2 times 5 is 10. So now I just have now I just have to subtract. Check your sign. 5 minus 4 is 1. And I bring my 10 over. So 1/2 minus 2/5 is equal to 1/10. Again, make sure that you know all three of these methods, but especially the first two, using your fraction bars and how to get equivalent fractions using those, and how to use the backwards Z guide to find your equivalent fractions in order to do your subtraction. Use your butterfly method maybe to go back and check your work and make sure you've done it correctly.